3D coordinates. Okay, we are on page 21. All right, so here's what you're going to do. I want everybody to hold out your right hand. Oh, no, in front of you. Okay, you have to hold it out like this, the way I show you. Okay, so this is x-axis. The direction it's pointing is x-axis, like you're going to shake someone's hand, okay? Zach, come back. Okay, right hand. It has to be right hand. Okay, and then you're going to curl your fingers. Okay, the direction you curl your finger is y-axis. Okay, so x, y. Okay, x, y. And then the direction your thumb is now pointing is z-axis. Is z-axis. Okay, so x, y, z. You have to use your right hand. If you don't use your right hand, it will be wrong. So what happened to... Huh?
X,
they curl
y,
your finger,
Z.
like it won't make any sense if it just goes backwards, right? So don't curl your finger all the way back. Just curl it 90 degrees. Okay. I don't know. Okay, so you can put your hand down now. So basically, what happened was you have to use your right hand. This is the right hand rule. In physics, you do this a lot, and then what happened was I was in college, I was taking my final, I think, or midterm, and I use my left hand because I usually write with my left hand, or I only write with my left hand, so I was like, and write it down, and I was like, why is all my answers negative? And then I thought about it, I said, right hand rule. So please use right hand only. Yeah, one of them's going to give you negative of the other, so. Anyways, come back. All right, so right hand rules. This is how you draw it. X-axis. So x-axis goes out, y-axis curls in, z-axis is like that. Okay, x-axis, y-axis, z-axis. All right, now that's the positive axis. So we are going to, okay, so let's just write this down in case you forget. So set your right hand straight. The fingers are now pointing towards the x-axis. Curl your fingers 90 degrees. The fingers are now pointing towards the y-axis. And then your thumb is pointing towards the z-axis. Okay, and then the axis you're pointing to are the positive direction. Okay, so let's help you figure out how to draw this. Now, if you usually draw, it shouldn't be too hard. Although some of the artists I had before are still kind of confused on how to draw these axes. But it's okay. We'll figure this out together. First, you're going to draw perpendicular axis just like x and y. But this time, it's not x and y. It's going to be y and z. Y and z. So you're going to draw the y-axis and z-axis first. The next thing you're going to do is you're going to draw the x-axis, and the way you draw the x-axis is you draw it 45 degrees through the YZ plane. So imagine you're creating a 45 degrees, and then you're basically imagining that it's coming out towards out of the screen, and that's x. All right, so in a 3D world, we have, basically it's, our world right now. Along with the three axes, we have 3 planes. The planes go XY, XZ, and YZ. I don't know if you can see it. So you have the YZ plane. You have the XY plane, okay? And then you have the XZ plane. Do I have a cube somewhere?
No, I see it.
You see it? Okay, so basically this is like a 3D figure, right? So you have one plane here, one plane here, one plane here.
Yeah.
Okay?
Very nice.
All right, now we are going to draw these planes. One more thing. Along with the 3 planes, we also have 8 octants. 8 octants means they are 8 I guess, areas that's broken up by these planes. So I'm going to try to draw this in a different color. You don't have to draw this, but basically, how should I draw this? Right, this is one cube, and then here you have another one, and in the back you have another one.
Whoa.
Right, so you basically have 8 cubes on the top, and then you're gonna have 8 cubes more on the bottom.
I see. I see.
You have 3 axes. They're going to be created by 8 boxes.
Oh. 4 on top, 4 on the bottom.
4 on top, 4 on the bottom.
Okay.
Yeah, so 8 octants. Oh, I'm sorry. All right, let's try drawing these. Okay, so we're gonna draw the point 2, -3, 1. So that's x, y, z. Yes.
Just to clarify, octants are like the quadrants.
Correct, the quadrants, yes. The quadrants in the 3D world. All right, so we're going to draw this point. So let's go ahead and draw our axis first. This is y, this is z, and then x comes out. All right, let's go ahead and create some markers. So,
Oh my goodness.
so the way you draw it is you make it like parallel to the other axis, because you're now in 3D. Okay, the z-axis is still like that. And I'm going to go in the negative direction. And the x-axis goes like this. So I'm thinking that if you usually draw, then it should be easy because you're just doing a 3D view. All right, we're now going to plot 2, -3, 1. 2, -3, 1. 2 is in the positive x direction. So we're going to start from the origin and go 2 out. Okay? Everyone's good with that?
Yeah.
Now we're going to go -3 in the y direction. Now this is a little bit tricky. We're going to go 1, 2, 3 to the left.
Yeah.
But it's not going to be exactly at this. It's not going to be exactly here because it is 3D. Okay, so it goes 1, 2, 3 like that. It goes slanted, I guess. And then it goes 1 up in the z direction. Yes, no. Okay, if you're not really good with that, I can show you another way, which some people told me it was more confusing.
How do you show the point?
How do you show the point? Great question. All right, so 2 is here. Okay, 2 is here. And then -3, so what you want to do is almost kind of like draw a line and then just kind of say -3 is right there. And then it goes up 1.
Oh, so you have to draw all the coordinates to be able to draw the point?
Yeah, kind of.
It looks like it could be like, x is 1, y is...
Yeah.
Right, yeah.
So the one's not completely at the one, right?
No, it's not because it's coming towards you. It's like a art lesson. Two, just so basically all of your axes are like this and then it goes like that. Or what else can you do?
We should get like a 3D
So, okay, it makes sense. Okay, so some people also just draw a box and then it's the corner of that box.
That's better. I like that.
So I don't know if it helps. Some people says it helps. Some people are like, no, that's worse. So you can draw a box.
I like that.
All right, so let's have you guys practice. Drawing, let's just draw this one. -3, 2, 5. Let me know when you're done. All right, A is -3, 2, 5. Okay, so I'm gonna draw it on the same one. Use a different color. Let's use black. Okay, so -3 is back here. 2, +2. So if you like the box method, you may want to draw it like that. So 3, 2. Please draw a like parallelogram. And then from there, you're going to go up 5. All right, so 5 is here on the z-axis. Now, you cannot just go over and then draw a 5. No, that is not where the point is. You're actually further back in the plane, so then you have to draw a box kind of like this. So on this corner, that is -3, 2, 5. Yeah.
So you just going 5 up from the y coordinate.
Correct, 5 up from the y coordinate, but to draw it realistically, you cannot line it up with 5 on the z. You have to make it a little higher because you're kind of like towards the back of this plane. Yeah.
Wait, so in reality, like for the z-axis, it would be like z equals 7 if we're just going off of the bigger axis.
Yes, or I'm not quite sure if it's exactly 7.
Not exactly.
Or like
Yeah.
close to 7.
I'm not even sure if it's even close to 7, but it's somewhere in the back, like a little higher than 5. All right, so that's that. For now, we're going to learn how to draw the plane in a few minutes, but before then, let me show you how to do distance formula and midpoint formula, which is so easy because it is just the same thing as the 2D, except we add a new dimension, 3D. So for example, distance formula, do you remember what the distance formula is?
Y2 minus y1 squared.
Plus x2 minus x1 squared.
Yep. So we had x and y, so then usually we do, let's say, start with x. x2 minus x1 squared plus y2 minus y1 squared. That is the normal 2D distance. Since we have a new coordinate from z, it's going to be z2 minus z1 squared. And we all add that together. So you just add a new dimension, that's it. How about midpoint formula? What's the normal midpoint formula? Okay, so midpoint, so right in between 2 points, x1 plus x2 over 2, y1 plus y2 over 2. And since we have a new dimension, z1 plus z2 over 2. So very easy. All you do is take your original formula and you add another dimension. All right, let's have you practice really quickly. Find the midpoint between these two and the distance. Distance and midpoint. All right, let's really quickly give you the answers. Distance formula, distance is going to be 2 root 17, I think. And then midpoint is 1, 1, 3. All right, so let's go on to the next page. Okay, we're going to skip this part. This is also very easy, but we don't have time to go over it. I do want you to go over this part, which is drawing planes. So we learned how to draw points. We're now going to draw planes. Okay, so in a 2D world, the only thing we can do that includes x and y is we create a line. So if you have 2 points, it creates a line. In a 3D world, since you have 3 points, you create a plane. All right, so let's try drawing this one. 12x plus 15y plus 20z equals 60. Okay, that sounds very crazy. We are going to start with x-intercept, y-intercept, and z-intercept. X-intercept is when what is 0, usually. Y is 0. But now that we have a z component, then what is x-intercept? Both of them are 0. So y is 0 and z is 0. So when y is 0 and when z is 0, what does x equal to? Okay, so when y is 0, that's gone. When z is 0, that's gone. So 12x equals 60. So x equals 5. So that means the x-intercept is 5, 0, 0. All right, y-intercept. Y-intercept is when what is 0? Everything else, x and z. Okay, so when x and z are 0, it's just 15y equals 60. So y is 4, so 0, 4, 0. Z-intercept. Z-intercept, y is 0, x is 0, y is 0. Okay, so that is 20, z equals 60. So z is 3, so 0, 0, 3. So what we're going to do is we know that this plane has to cut through these 3 points. So let's go ahead and draw this. Okay, draw our 3D coordinates again, y, z, x. We're going to graph these 3 points on there. X is 5, 1, 2, 3, 4, 5. Y is 4, 1, 2, 3, 4. Z is 3, 1, 2, 3. Okay, what we're going to do is connect these 3 points together. And that shows me the plane. Okay, now let me ask you a question. Is the origin in front of the plane or behind the plane? Behind. You guys can tell, right? The plane is in front. So to make this a little bit easier to see, what they would like you to do is make everything that's behind the plane dashes. So let me... No, I just erased it, but I cannot do it on here. This is... okay. So this, yeah, no, because I'm on a different app, so I can't do that. Okay, so this is solid. Everything else behind is all dotted. Because what I'm trying to do is show that it is different. Can you guys see it? All right, so.
So is the plane like a pyramid thing?
No, it's not a pyramid. It's just that at this point that I drew it, it's looks like a pyramid, but it's cutting, right?
Okay, so it's just a flat thing.
Yeah. It's a flat thing. I mean, it'll go on forever, but you don't want to draw everything. It gets really crazy.
Forever?
So you're just
it's a plane. It cuts.
Oh yeah.
So you're just trying to dot lines to show. You're trying to dot lines to show those lines behind.
It's behind, right? Correct.
That's what you want to draw on the test?
Yeah, and on your homework. All right. The last thing I'm gonna. What's that?
So we have to find the plane first, then eraser.
Yeah. Right. All right. The last thing I'm gonna do is show you the formula you had to memorize for the test.